Student, I am going to teach you about 4.4 Intermolecular Forces. In this topic, we will discuss about van der Waals forces, dipole-dipole forces, London forces, and hydrogen bond. First, I will explain to you what is the intermolecular forces. Intermolecular forces is attractive forces between neighboring particles, which is atoms, molecules, or ions. In this figure, we have HCl molecules are close to each other. So, intermolecular attraction exists when the molecules are close to each other. The two types of intermolecular forces, we have hydrogen bond and van der Waals forces. Van der Waals forces are weaker than hydrogen bond. Okay, next, I will explain to you what is the van der Waals forces. Van der Waals forces is an attractive force between the neutral molecules. We have two types of van der Waals forces, dipole-dipole forces and London forces, or we call dispersion forces. We go to dipole-dipole forces. Dipole-dipole forces arise from the attraction of the permanently positive and negative end of a neutral polar molecule. Okay, for example, HCl molecule. Hydrogen has the partially positive, while chlorine has partially negative. When the molecules close to each other, so partially negative for chlorine and partially positive for hydrogen are attract each other to form dipole-dipole forces. A more polar molecule means have large dipoles moment has a stronger dipole-dipole forces. So more energy is needed to overcome the strong dipole-dipole forces, so boiling point increase. In conclusion, the more polar the molecules, the stronger the dipole-dipole forces, the higher the boiling point. Okay, in this figure, we have example of propane and acetaldehyde. As you can see, both propane and acetaldehyde have same relative molecular mass. But acetaldehyde has highest boiling point than propane. Because acetaldehyde is a polar molecule and has stronger dipole-dipole forces, while propane is non-polar molecules and has London dispersion forces. Dipole-dipole forces is stronger than London forces. Therefore, the boiling point of acetaldehyde is higher than propane. Next, I will explain to you what is the London forces or dispersion forces. London forces is a weak temporary forces of attractions that occurs between non-polar molecules. London forces exist in all atoms and molecules. Forces arise because electrons in atoms or molecules are in a constant motion. London forces are weak because the temporary dipoles change with the motion of the electron. Next, an atom has proton in its nucleus and electrons surrounding the nucleus. So, the negative charge of the atom is spread evenly around the nucleus. So, at any instant, one side of the molecule has highest electron density than the other side. In this figure, you can see the other side has the highest electron density is partially negative, and the other side we have lower electron density, we call partially positive. So the atoms or molecules become a small instantaneous temporary dipoles. The temporary dipole can induce a similar dipole on a neighboring atoms and can be attracted to one another. Okay, in this figure, we have A atoms and B atoms. So a temporary dipole in atoms A induces a temporary dipole in atoms B. So this interaction is called London forces or dispersion forces, and only significant when atoms are close together. So, London forces are weak temporary forces of attraction that occur between nonpolar molecules. And London forces exist in all atoms and molecules. London forces also, the forces arise because electrons in atoms or molecules are in a constant motion. So, London forces are weak because the temporary dipole changes with the motion of the electron. Okay, next, I will explain to you what is the hydrogen bond. Hydrogen bonding is a special type of intermolecular attraction. There are two requirements for the formation of hydrogen bond. First, hydrogen bond forces between polar molecule with partially positive hydrogen atom bonded to highly electronegative atom, fluorine, oxygen or nitrogen. Means hydrogen atoms bonded with fluorine, hydrogen atom bonded with oxygen, or hydrogen atom bonded to nitrogen. Second requirement is partially negative lone pair electron on fluorine, oxygen, nitrogen of another molecule. So, we have two requirements for the formation of hydrogen bond. Okay, we have three examples of hydrogen bond. Okay, first, hydrogen bond in hydrogen fluoride. Second, hydrogen bond in ammonia molecules. In the ammonia molecules, the nitrogen atom has one lone pair of electrons. This means that each ammonia molecules can form one hydrogen bond. Okay, next, hydrogen bond in water molecules. In the water molecules, the oxygen atoms has two lone pair of electrons. This means that each oxygen atoms in the water molecule can form two hydrogen bonds. Each water molecule has two hydrogen atoms that can form hydrogen bond with two others water molecules. So, water molecules can form four others neighboring water molecules by hydrogen bond. Example of hydrogen bonding. First, hydrogen bond between hydrogen fluoride and water molecule. Okay, here hydrogen is bonded to the fluorine. Second, hydrogen bond between ammonia molecules and water molecule. Okay, you can see hydrogen is bonded to the oxygen. Next, hydrogen bond between ammonia molecules and hydrogen fluoride. Okay, hydrogen is bonded to the fluorine. Okay, next, enrichment question. Question number 1. Which of the covalent compounds can form hydrogen bond between molecules? A. HCl, B. PH3, C. HBr, D. HF. So the question asks, which of the covalent compounds can form hydrogen bonds between molecules? So the answer is D, because hydrogen is bonded to the fluorine. Next, question number 2. Which of the following compounds has van der Waals forces only? A. Water, B. Alcohol, C. Tetrachloromethane, D. Magnesium chloride. So the question asks, which of the following compounds has van der Waals forces only? So the answer is C. Tetrachloromethane, because water and alcohol can form hydrogen bond and magnesium chloride has ionic bond. Question number 3. By referring to the following table, which of the following answer is correct? So we have 4 types of molecules. Okay, molecules A, B, C, and D. So we have London forces or dispersion forces, dipole-dipole forces, and hydrogen bond. Student, you have to identify the type of intermolecular forces exist in these molecules. So the answer is D. CH3 and H2 have London forces, dipole-dipole forces, and hydrogen bond. Thank you.